All right, so we are officially moving on to triangles. So for the next few weeks, we're really going to be focusing on everything relating to triangles, and we're going to start with congruence. Now, you know when things are congruent, that means they're exactly the same shape and the same size. Another word that goes with that we've used in the past is rigid motion. All right, that means that these are translations or reflections or rotations of one another. Okay, so when we have congruent triangles, there are 3 sets of congruent sides and 3 sets of congruent angles. So if we start with this congruent statement right here, triangle ABC is congruent to triangle DEF. You all already know that that means they're in that order for a specific reason. So for example, if we talk about our angles first, angle A and angle D are going to go together. So remember, we mark those with this little kind of arc. And we can say, if we're going to name the angles, which I want you to do in your notes, we can say that angle A is congruent to angle D. We could also say that angle B is congruent to angle E. And remember, we can mark that. Since this is a different angle, we'll use 2 of the little arcs to mark that one. And then angle C is congruent to angle F. And I'm getting all that from looking at these congruent statements and picking the same spot. All right, we can mark C is congruent to F. Okay, we also know that there are sets of congruent sides here. So if we pull 2 letters at a time from the statement, for instance, AB and DE go together, I can mark those, and I can use like one little hash mark. So if we're going to list sides, AB, remember these are segments, so we need to put the little bar over them, is congruent to DE with the little bar. Don't forget that bar, okay? We can keep going. BC and EF would be the next one. So I'm going to put 2 arcs here, 2 hash marks there. So BC is congruent to EF. Now, I'm showing you a really basic example in your notes, but these might be turned different directions. So it might not be just that you can just look at them and see which parts match up. So you really have to use that congruent statement. The last one's going to be AC is congruent to DF. All right. Now, we're going to be doing some proofs with these, and the problem is right now, if you wanted to know that 2 triangles were congruent, I would have to tell you all 6 pieces of that information. And that's a lot of information for you to just say that they're the same size. Like sometimes you can look at it and tell without me telling you the measure of every single angle and the measure of every single side. Okay, so the last little bit of notes you're going to take tonight in preparation for the activity we're doing tomorrow. We're going to be doing some proofs with what we're doing. So that's just those same statements and reasons. And you're going to be okay on those, I promise. These are kind of nice because they have a structure or a format they follow every time. But some things I want to tell you. So first of all, the definition alone of congruence would require that you have 6 pieces of information. So those 6 pieces are 3 angles and 3 sides for you to prove triangles are congruent. So that's a lot of information, and I can show you what I mean in class tomorrow, but you wouldn't want just the definition. So what geometers, the people who came up with geometry, what they did was they came up with some kind of shortcuts for us so that we didn't have to do the whole problem. We could just kind of use a little bit of information to say what we wanted to say. So some notes about the shortcuts, and we're going to learn what all those shortcuts are in class tomorrow. That's what you're going to help me figure out, is that you need to move in order around the triangle. So I'm just going to explain to you. This first one says ASA. That stands for angle, side, angle, okay? And they have to be in that order. So for instance, if I choose this angle down here, and this angle at the top, it says the side is in between those 2. So I need to be using the side in between them. So angle, side, angle would be these pieces of information. I've kind of highlighted them. It would be this angle, this side, and that angle up there at the top. All right, I can even write that with letters for you if you want me to. If this is A, B, and C, that would mean you knew information about angle A, you knew information about side AB, and that you also knew information about angle B. That would be angle, side, angle. In comparison, this next one says angle, angle, side. So that means I still have my 2 angles, And right now, you shouldn't be like curious about, well, why are you picking those two angles and not another two? Well, you'll see why I'm doing that tomorrow, okay? I just need you to see on this one, the side is not in between those two angles. So I don't want to pick that side I picked before. I need to pick one that's kind of on the other part of the triangle so that it's not in between. This would be an example of angle, angle, side. And if I named those, just so you can kind of have some good notes for yourself, that would be like angle A, angle B, and then side BC. That would be an example of angle, angle, side. All right, have those notes. I'll see you tomorrow.